We need to prove that tan 2b plus 1 over cos 2b equals to cos b plus sin b over cos b minus sin b. We are always going to start with the most complex side. Here we will work with the LHS, the left hand side. LHS, which is equals to tan 2b plus 1 over cos 2b. Right? And we need to convert everything into sine and cosine. So the first step is to convert everything into sine and cosine. We know that tan 2b is the same as sine 2b over cos 2b plus 1 over cos 2b. Okay? Now step 2, we're going to combine the fractions. Because our denominators are already the same, which is cos 2b, we can write everything under the same denominator and just add the numerators together. Right. And then step 3, we know that sine 2b can be written as 2 sine b cos b. It's a special angle. Plus 1. All over cos 2b, we know that it can be written as cos 2b has 3 of them. But I'm going to choose this one, cos squared b minus sine squared b. I'll tell you why I choose this one. Because I see that here I have something that has both coses and sines. You see it? So that's why I chose this one. And then let's go on. The one, we're going to change it to sine squared theta plus cos squared theta. And I'm going to put sine squared b here plus cos squared b at the end. And then in the middle I have plus 2 sine b cos b. You can see, ladies and gentlemen, that this part is this part. And then sine squared b plus cos squared b is the 1. Remember, the Pythagorean identity of 1 says it's the same as sine squared b plus cos squared b. Okay. All over cos squared b minus sine squared b. Then, ladies and gentlemen, if you check here, on top we have a perfect square trinomial. Because you have a perfect square here, you also have a perfect square there. So that tells you you have a perfect square trinomial. And then we can break it into sine squared b will break into sine b and sine b. Cos squared b will break into cos b plus cos b. And then the sign, you take the sign of the middle term. So it's a plus and a plus. If you were to FOIL, you will still get this guy here. Okay? So that's fine. Now let's go to the bottom. At the bottom, what do we see? We have a difference of 2 squares. And it's going to factorize into cos squared breaks into cos b and cos b. Sine squared breaks into sine b and sine b. And then difference of 2 squares is plus and minus. The signs must switch. And this bracket will cancel that one. Right? So on top we're left with sine b plus cos b over cos b minus sine b. Now let's go and check what we're proving. We're proving that cos b plus sine b, which is there. Sine b plus cos b is the same as cos b plus sine b over cos b minus sine b over cos b minus sine b. So we have proven it. Therefore, the left-hand side is the same as the right-hand side. All right? Thank you very much, ladies and gents. Now, they say on part B, we are asked to say, they say hence we need to simplify cos 15 plus sine 15 over cos 15 minus sine 15. Remember, ladies and gentlemen, this part here is exactly the same as that part. And we have proven that that part is the same as tan 2b plus 1 over cos 2b, right? Plus 1 over cos 2b. And you can see that our b in this case is 15 because 15 goes with that. You see, 15 goes with that. 15 goes with that. 15 goes with that. So which means I can put 15 here and I can put 15 there, right? Which means this guy here will be the same as tan 2 times 15 plus 1 over cos 2 times 15, right? Which becomes tan 30, 2 times 15 is 30, plus 1 over cos 30. Okay? And then we know that tan 30 is 1 over root 3. Right? It's a special angle. And we know that cos 30 is root 3 over 2. So here we have plus 1 divided by root 3 over 2. That is cos 30. And then pressing everything on your calculator, we're going to get square root of 3. And that is our final answer, ladies and gentlemen. Thank you for watching. If you found this video helpful, please don't forget to hit the subscribe button. Thank you very much, ladies and gentlemen. Aluta continua. Tango.